Thank you, and welcome everyone to our VCF 9.1 adoption series. If you've been with us for some of the earlier sessions, welcome back. If you're just getting started with us, welcome. My name is Kyle Gleed. I'm going to kick us off. And again, this is a series. We've gone through the last 5 weeks and we've gone through a number of different topics. We started with a discussion about design, where we went in and we introduced you to the concepts of designing a VCF private cloud. We talked about VCF fleets and instances, how to basically stand up that initial management domain, and then how to design this and scale this for your needs according to whether you're doing a single deployment or a cross-region deployment. We even went into a little bit of discussion around upgrade planning. We then followed that up with a live demonstration of the VCF installer. We went through and we actually did an actual install together where we went in, logged into the VCF installer, went through, connected our software depot, downloaded our binaries, and kicked off a deployment and looked at that deployment from beginning to end. And then we followed that up with a little bit of commentary about brownfield deployments as well. We then spent some time talking about workload domain and workload domain management, how to commission host, how to create and scale our workload domains. And then we looked a little bit about how to do patching and upgrading for those domains. And then last week, we had our experts from our VCF operations team come in and introduce us to VCF operations. They gave us a good overview of all the capabilities inside of operations, the UI, all the things in the UI, how to do capacity planning, cost planning, how to do showback, and we got into fleet management. And that brings us to today. We're here August 12th, and this is the fifth, and this will be the final for this initial series of 5 presentations. And today we have Maher Alisfar along with Vincent Riccio and Scott McDermott, who are going to be talking to us about VCF automation. So today is a deep dive into VCF automation. We're going to be going over all things related to using VCF automation to now consume this private cloud that we have built. And as the slide is showing here, it's going to be very, very heavy in demos. We tried to make all these sessions very demo-led, so we're not spending a lot of time on PowerPoint. These are all demos. And so today will be no different. We do have a number of experts standing by in the Q&A. Again, do post those questions in the Q&A. We look forward to your input and your questions, and those will help to, we'll do our best to answer those. When we get done with today's session, you will get another survey. We do ask you to make sure you complete that survey. Based on the survey feedback we've had from the initial 4 sessions, we are planning to revisit our adoption series and do more of these, where we will have more of these demo-led presentations and make those available. The exact content and time is still being determined, so this is a good opportunity to get your feedback in and let us know what you would like to hear more about, and we will definitely consider that as we go forward. Now, one of the most common questions we've been asked, of course, across all 4 of the previous weeks, and I imagine we'll get this question today, is, hey, where can I get that copy of the recording for those previous sessions? So the best way to get a copy of the recording for these previous sections is to go out to VMware Cloud Foundation, go out to Google, just do a search on VMware Cloud Foundation webinar series. When you do that, it'll bring you to this page. And here you can see here's part 4, here's part 3, part 2, scroll down, part 1, and then of course, part 5 will show up here. So that is the best way to get access to these recordings. And they're available for you. You can go out and view those at any time. For those who have been with us through all 5, we do remind you about our giveaway. So if you have attended all 5 of the sessions, make sure you register, and hopefully you can be one of those winners and get some of the giveaways that we have slated to give away at the end of this. And of course, a plug for our upcoming VM Explore event in Las Vegas the end of this month. So a lot of us, all the presenters, we're going to be there. We're going to be presenting on these topics. So we invite you to take what you've learned in this webinar series and to come to Explore and to build on that, to meet the presenters and to, kind of further your adventure into Cloud Foundation. And with that, I'm going to go ahead now and I'm going to get off the mic and I'm going to hand it over to Maher, and he's going to kick us off and give us our deep dive into VCF automation. So Maher, it's all yours.
Thank you, Kyle. Hello, everyone, and welcome to week 5 of the Inside VCF 9.1 series, from design to deploy to value delivery. My name is Maher Alisfar. I'm a product marketing engineer within the VCF division at Broadcom. It's a pleasure to be here with you all today. And of course, we saved the best for last. Today, we're going to focus on consuming the VCF private cloud, specifically looking at VCF automation, how we set it up, configure it, and ultimately start consuming the private cloud services. Before we get started, just a quick housekeeping items that Kyle already touched on. As usual, the slide deck and the recording will be shared after the session. Please try to keep your questions related to the topic at hand so we can stay on track. We have a great panelist standing by to answer your questions. And finally, everything you will learn today is running in a live environment. Hopefully, everything behaves itself. We have a lot to cover and quite a bit that I want to show you live. So with that, let's get started. Here is our agenda for today. So we're going to get a solution overview on what VCF automation is. And then we get into the provider administration, organization administration, and then finally consuming and looking at the consumer cloud experience. Now, before we begin the end-to-end setup, let's first take a look at the role of VCF automation plays within the VCF or VMware Cloud Foundation. VCF automation provides the modern cloud consumption interface that sits above everything, above the core VCF infrastructure services like vSphere, vSAN, and NSX. Its main purpose is to turn those infrastructure capabilities into governed self-service cloud services that you as users can consume more easily to deliver and manage things like virtual machines, Kubernetes cluster environments, containers, and private AI workloads. On the VCF provider side, enterprise IT and or platform teams will remain in control. They define the infrastructure, the networking and security, governance policies, tenancy model, everything that we will see getting done in the provider side of things, and also including the content available to users. On the VCFA consumer side, developers, DevOps engineer, data scientists, and application teams receive a rich self-service experience. They can deploy services through a catalog or infrastructure as code without needing direct access to the underlying VCF components. Really, the goal is to provide a consistent private cloud experience across the data center, edge, service provider environments, and connected public cloud. With that foundation established, we are now going to walk through the complete VCF automation 9.1 setup and configuration after the initial VCF private cloud platform deployment that we saw in the previous weeks. Okay, so before I even start, I'm going to exit my PowerPoint and just show you a pre-established and configured, just so you can have an idea of what we're striving towards here. So this is the organization portal in VCF automation. And under build and deploy, this is my overview page, of course. I see the number of projects, the namespaces, the policies, the services that I have access to, and also the catalog. This is the front end for the project users to be able to go into the catalog and self-service ready to deployment application infrastructure, whether it's virtual machines, whether they're complete application, like, for example, this bookstore application, which is a Kubernetes microservice application, provisioning web servers, provisioning, running orchestrator, for example, workflows as X as a service. In addition to that, you have access to these services, IaaS services, that you can interact directly with, such as the virtual machine service, and we will be able to actually walk through those actual services once we set up everything. Now that you have an idea in terms of the what the UI is going to look like, I'm going to close this ready to go environment, and we'll jump back into what actually we are going to walk through. So the first section is going to be all about provider administration and configuration, as you can see on the screen. And we're going to tick mark everything on the screen as we go through so we can stay on track for the remaining of this live demo. All right, so first thing we need to do is just access, how do you access the provider portal, and then look at a few things before we start configuring things. So I'm going to switch to the environment I have. Just so you all know, I have 3 main tabs open on my desktop. I have the vSphere client that's connecting me to the VCF instance that we built in the previous weeks. I have operations also, because there are some steps where we will have to go into operations to configure things like the provider pricing. And then we have VCF automation. VCF automation starts asking you, what is the organization name? And of course, we haven't created any organization as of yet. So the default one to get into the provider portal to get started is called system. That's the default organization. And as you can see, VCF SSO, as we saw Andrew do in the last week when he configured VCF SSO, it's been pushed to VCF automation. So we could actually leverage that to be able to access our provider management, since we're being given access to do so. So let me go VCF SSO here, log in. And I'm going to log in with the administrator at domain. And we get a disconnection. All right, just give me 1 second. Log in with the local admin. Okay, let's get the passwords. Once we log into the provider portal, and because VCFA is not set up yet, you're basically land on the welcome to the automation or VCF automation page. You have 2 types of setup. You have the quick start if you just want something quickly to set up as a single tenant and automate most of the setup. You can use the quick start. It's not something that we recommend in production. So for this demo, we're going to go with the manual setup, because we have a lot more control here over some of the parameters that we use when we're creating the tenant. So you can either click the Get Started here, or click on the top left corner to get you to the infrastructure overview page. Of course, you have a welcome page. We can see recent task at the bottom. I'm going to close that one. And right away, you can see a getting started workflow, that 5 steps that we will go through together, and as we set up this. But before we do that, there's a few things that you want to really first make sure that you have. For example, the first thing is making sure that we have our VCF instance. This is the SDDC manager component, and then the connections to see our vCenter and NSX manager connections endpoints. So we can see that we have a management vCenter, we have a workload vCenter, and we have our respected NSX manager for each of those domains. So NSX management and an NSX manager for the workload domain. So we see our connections just okay. If in case for whatever reason you logged in quickly into VCFA and did not see your connection endpoints, you can always go to the SDC manager and refresh. It'll bring in those connections automatically. Second here, let's go ahead and see if we actually see our supervisor. So we do see our supervisor, which currently is on the vCenter and the workload domain. If we go quickly to the vSphere client, you can see I can see both environments here, management and workload domain. And our supervisor, as we can see here, is in the workload domain. So I have 1 supervisor right now backed by 1 cluster. This is as simple as it can be. Okay, so now that we kind of went through and made sure our connection endpoints are there, we can go to the infrastructure overview and start going through. And the first thing we're going to do is create our region. So we can click on the start here. Of course, there are a lot of different inline help in the UI to tell you what a region is. And very simple, a region is 1 or more supervisor. So it consists of 1 or more supervisor. And if we click start, it takes us right into the creation of a region workflow. Or we can just click on the regions menu on the left-hand side under the infrastructure overview. So here I have already these regions, and so we're going to call this US West A, and then I can see the NSX local manager as the next step. One of the things important here is that we can only, the region only can consist of supervisors that's talking to the same NSX manager. So if we select the NSX manager for the management domain, as you can see, we don't have a supervisor deployed in the, technically, I mean, you can, but usually customers do not deploy a supervisor because there's no workloads in the management domain. So we did not deploy a supervisor in the management domain. But if we do select the NSX manager for the workload domain, then we discover the supervisors that are using that NSX manager as the networking stack, basically. So we're going to select our supervisor, and next we're going to go and select our storage class. So these are all the storage profiles that you see in vCenter exposed here, representing the back-end storage. Here you can select NFS, fiber channel, and in our deployment, as you've seen in the previous week, it's vSAN. So I'm going to go and select our default vSAN storage policy. You can add one or more storage classes, depending on what backend storage you want to make available in the region you're creating. Now that we selected that, we hit submit, and that's going to take us into creation of our region. Once the region is created as a construct in the provider portal in VCF automation, we're going to see its status here, and it's ready. We can always click the double arrows to see, for example, what supervisor it's living on. Right now, it's only includes one supervisor, and it has this much this much CPU and memory in terms of the resources that we can consume on that supervisor. Awesome. So if we can now go back to the infrastructure overview, we see a green check mark on our create region, and we can safely move to the next step, which is external IP block. And this is basically the subnet or that's going to represent the external network. So right now, all we're doing is we're defining the subnet that we want to use when we actually need to connect to the external network. Clicking start will take you under networking to the external IP block, and we'll give this a name. So in this environment, I have two VLANs, VLAN 25 and VLAN 27. We have one region, so I'm going to select our region, US West, and you can see here a little of a pro tip. I personally like to include the region where I am making this external IP block available in for just identification, basically, knowing that, oh, this is the US West specifically, unless the region, for example, is valid across multiple regions. We only have one region right now, so this is our external IP block name, and here I have a little option if you want to hide any of the IP block details from the tenant. So if you're like a service provider and you don't want to expose the external IP block to the tenant, then you can toggle this on. For enterprises, of course, does not make any difference. So we're going to keep it off. We don't want to hide the external IP block. We actually want the organization to see it. Clicking next, and now we can configure one or more CIDRs. You can see here an external IPAM. We do integrate with Infoblox if Infoblox is already integrated with NSX to bring those subnets in via that external IPAM connection with Infoblox. For us, the CIDR that I'm using for this is going to be a /25. So this is my subnet .9.0/25, and then you have the way of using the CIDR to establish the range that you want, or you can go to the IP address range and add those ranges, especially if they're not in contiguous fashion. For example, if you have like separate ranges here and there, top of the range, middle of the range, or bottom of the range, you can add them here, and you can also exclude any IPs if you want to. So we're going to hit next, and that takes us to our default IP quota, where we can specify the number of IPs we want to restrict this IP block to. Right now, I'm going to set everything to unlimited. So number of single IPs, number of CIDRs, and maximum subnet size that you want specifically to apply to this specific IP block. Next, and then we review and complete, and we create our external IP block. So we've added the subnet for VLAN 25, but we still haven't defined how do we exit to this external network. And this is where it takes us to step 3, and that's the external connection. The external connection defines the external network or the next hub of connectivity for the organization once we allocate this stuff to our tenants or organization. So we're going to hit start. This takes us to the external connection. And let's see here. And this takes us to the external connection. And right away, we get into this centralized connection. This is one thing that we are actually enhancing in the upcoming release. The external connections that I want to create for the US West is actually distributed, and I'll talk about what that means in just a second. So let me give this a name first. I'll go to my cheat sheet here. And this is going to be US West external connection. So again, I'm using the region at the beginning of the name. And this is going to be for US West A region. Hit next. And as you can see, we don't see any tier 0 gateways. The reason for that is that the region that I created, which is US West A, is actually a distributed connection. So for that, what we can do is go back to the external connection, and instead of being on centralized, we can go to distributed. And this is where I can sort of explain to you the different connectivity architecture that we support that usually you would actually find out in terms of how your VI admin configured your supervisor in the respective vCenter. Distributed connectivity enables north-south traffic routing directly at the hypervisor level using the transit gateway with distributed external connectivity. This is so we can support things like DHCP, external IPs, and allow service stateful netting and load balancing. The next one is centralized. This is where we can use edge clusters. If you're using edge clusters, again, to route all north-south traffic through NSX edge nodes for centralized service delivery. And if we switch really quickly to vCenter, and if you, for example, you didn't know and you're not the person who said it, but you still have access, I can easily go to the workload domain vCenter, click on networks, and click on transit gateway. And right away, I can see, for example, the connection type that this domain was configured on. And as you can see, when we deployed the workload domain to this environment in the previous week, we chose distributed. Okay, so with that being said, so I'm going to switch to distributed VLAN connection, and this is where I'm going to create my external connection that's going to leverage the external IP block that we just created for VLAN 25. So I'm going to select US West A, give it a name, and this is where the connection details. So the subnet CIDR I created as the external IP block for our external network is on VLAN 25. And it's actually going to use 9.1 as the gateway. So this is the gateway CIDR, meaning the gateway of the VLAN 25. You have an option here to actually create a dedicated, use this as a dedicated for a specific subnet. So this is going to be a VLAN. If you don't want to share this VLAN with any other VPC subnet, then you can toggle this and it will be only allowed, you would not be able to share this with any other organization. In our setup, we actually wants to share this VLAN. This VLAN, let's say it could be a really big VLAN subnet like a /16, and it's going to be shared across multiple tenants in the organization. But you do have an option if you have a small subnet and you want to make sure that it is dedicated inside the organization to a specific VPC subnet, then you can toggle this. We're going to leave it alone and hit next. And then I can see the associated external IP block for VLAN 25 that I just created or saw me created a few minutes ago. Hit next. We'll look at the summary and hit create, and that's going to create our external connection. Now, you can see it's created, it's normal, it is shared, not dedicated because we didn't toggle that option, and it's using VLAN 25 with this gateway in the US West A region. If we go back to the infrastructure overview, just so it let us know, okay, what do I need to do next? And this is takes us to create organization, which is a step 4 in our demo. And organization, as it says here, it's a top-level entity used to group and manage resources, users, policies, IaaS services, etc. So this is my tenant. The overall is tenant management. Tenancy is support of tenancy is something we can do in the provider portal in VCFA. And what I'm doing right now is creating my first tenant, aka our organization. Basically, our organization is going to called the big famous Acme organization, and we're going to hit create and continue. One thing here to note: the minute you hit on create and continue, it's actually creating the organization. So if at any point we hit cancel and get out, we will have an organization that we would have to go back in and complete its configuration, which is something you can do. So here we're assigning it a region quota. A region quota is how much resources I'm going to allocate this organization. And that's what a region quota is. And those resources are going to come from the US West A region that we just created. In 9.1, we've introduced something super simple and super helpful for a lot of customers that wants to start really quickly. And that's basically sharing the entire capacity with this organization. So what that means, all the CPU and memory and storage available on the supervisor in this region, or the supervisors in this region, because it can be one or more supervisors, we're going to share the entire capacity and resources with this organization. That's an option available to you, and it tells you here that we're actually sharing the entire 114 gigahertz, the 388 gigabyte of memory, and all the t-shirt sizing, all the VM classes that are defined on the supervisor. And of course, the storage class available, and this is the only storage class that we made available in the US West-A region. If you don't want to use the entire, you can always say share a portion. Be also very selective in what one supervisor you want resources to consume resources from. Here I'm going to make sure it add all available resources, and then I can go and add the capacity I want to assign this tenant. So I want all my zone to have the same tenant. If you want all the zones to have similar limits and reservations, then you can toggle the checkbox. If not, if every zone is going to have different, so you don't check it, and you will be able to select the zone in that supervisor and set its limits and reservation. To get things simple, we're going to share the entire capacity. Why not? It's a lab. And then we're going to assign and continue. And then we're going to get to the networking section in terms of setting the networking boundary that this organization is going to operate within. We've already created the US West external connection that's going to use VLAN 25 and the external IP block that we've defined. So that's what I'm going to select. There are some advanced settings here around things. You can select your VNA cluster, which is the virtual network appliance. Very similar to the edge cluster and nodes, except that it does not have an overlay. And this is the VNA usually are responsible for enabling those stateful network services that we're going to need when we actually need NATing and need load balancing, etc. So this is the VNA cluster that my VI or virtual infrastructure admin set up for me on the workload domain, or when we actually deployed the workload domain during the creation of the workload domain. There are a few things here for private IP that you can override. This is what we use out of the box for two types of subnets. So we have the public subnet that's going to get IPs from that external IP block. And then we have a transit gateway IP block. The transit gateway IP block is inter VPC connectivity. So VMs can connect across VPCs. And then you have the default private VPC IP block. This is only operates within a VPC. So the IPs doesn't get advertised outside the VPC subnet. So we're going to leave things as default. And here it's telling us what's going to happen when we assign and continue. We're going to create a default virtual private cloud networking, so for the organization that the organization can utilize right away. We're going to create a default transit gateway to enable us to get to the external or the outside world. We're going to have a source NAT for when we need those workloads to interact with the outside world. Like if you connect a virtual machine to a private VPC and you want it to hit the internet, for example, that it's going to go through that default source net. And then we have a default connectivity, which will all go through and see get created in the org once we log in into the org that we're creating. So we're going to hit assign and continue. And the last thing left for me to do here, well, there's a few things, is assign the first user. And the first user is the built-in org admin, if you will, that I'm going to, as a provider admin, I'm going to hand the keys to and say, okay, your org is created, your tenant is created. Go ahead, here's the credentials that you can use to access it. And this is exactly what we want to do. And we gave it the organization administrator role. I'm going to save this because we're going to use this later on. Now, if we go back to the infrastructure overview, we see that we went through literally the 5 steps in the minutes we spent setting up the organization. There are a few things that we need to do, for example, that we will need later. So one of the things that you will need to do as a day 2 operation is clicking into the Acme. This is the organization we created. This is our region coda, where we can see that we've assigned it resources from the US West. This is our networking in the US West region, where we assigned it regional networking for VLAN 25. And then our first user, and then we have settings here. In the settings, as a provider, you have actually the option to allow this organization that you just created to be able to subscribe to external published content libraries available within their data center. Also, and with our collaboration with Canonical, you can actually allow the organization to subscribe to a Canonical content library where it already have Ubuntu images, for example. So I'm actually allowing the organization admin to be able to do those things. Subscribe to external content library or subscribe to Canonical. One little thing I want to do that the workflow did not do for me is basically the reservation. As you can see here, my limits is the entire capacity of that region, but my reservation for memory and CPU is 0. And we need reservation later on as we progress into this demo. At the end, when we use the container service to provision containers, we will need reservations. So what I'm going to do, I'm going to just simply hit the 3 dots and hit change this to gigahertz and a gigabyte. And I'm going to assign the reservation for this is going to be 10 and 10. So 10 gigahertz of CPU and 10 gigabyte of memory. And this should automatically configure our reservation and enable it on the region coder that we have here. Make sure that you actually select gigahertz and gigabyte. A lot of the times I forgot and I ended up setting a reservation 10 megabyte and 10 megabyte and 10 hertz basically. Okay, so now that we did this, there is if we go back to our slides, so we did a provider portal overview, we configured regions, we configured our external IP block, we configured external connections, we create an all apps organization, which is the Acme organization. And now what we want to do is really share a VLAN subnet. So we've created already a networking on VLAN 25, but what if you have VLANs configured on the top of the rack switch that you easily want to share with the environment or the organization that you created? So what we're going to do, we're going to now go in and show you how that is done. So in the networking, as you can see, in the US West region, under subnets, we have an ability to actually share subnets. However, we haven't created any subnets. So we need to define what that subnet is first by going to the subnets menu and clicking on new. So the network that I want to share with this is you can add all your VLANs here. So the next VLAN that we have on hand is VLAN 27 in this lab. And I want to make this VLAN 27 available to the region US West A. So any region allocation from this region to a tenant can actually leverage this VLAN and be able to connect virtual machines or workloads to it. Next, what is the VLAN ID? Obviously, it's VLAN 27, so it's 27. And we want the gateway subnet for VLAN 27. And that's where I'm going to put here. So this is 10.1. and we have 9.1 for VLAN 25 as we saw earlier. I'm going to hit next, and I'm going to hit create. What this is going to do, it will automatically generate an external IP block based on the CIDR subnet that we provided. And if we actually go to our external IP block, you see the 10.0/25 got created, and we see an external connection also created for VLAN 27. Now I can go to my organization that I created, Acme, go to my networking, which by the way, I can also click configure here if you wanted to. It's the same thing. And go to the subnet sharing and click on share. And now I can see VLAN 27 is available as a subnet I want to make available to my tenant. So I'm going to share it, and this is going to show up here. And now this VLAN should be available for our tenant. Okay, so one last thing we want to do before we actually jump into the org and verify some of the stuff that we set up. So we're going to log in as the org admin. Before that, I can go and do a content library. So the content library that you see here in the provider portal, this is something that gets shared automatically with all the tenants you end up managing. If you don't create it, then it's one of the responsibilities of the org admin. So the org admin, when they log in into their Acme org, they can set up their own content library. For the sake of the demo, and just to make things quickly, you can see I've set up a content library already in the management domain, and I called this VM Service Content Library. This VM Service Content Library, I've uploaded two Ubuntu Cloud images, Ubuntu 24 and Ubuntu 26. So what we're going to do, we're going to actually edit this and copy the link. It's publishing is enabled on this content library, so I'm going to copy the link to point to this content library when we're creating this, and it's going to be able to automatically sync the images within that library. Now, you absolutely don't have to go to vCenter to do anything. You can actually create this here and upload the images right away from here. I'm going to leverage the subscribe to external library and give this a name. We'll call this a provider content library. Hit next, and in my settings, I'm going to again go into my edit here, copy the link again, and put the URL and hit next. And I want this content library to be available in what region? So again, we've only created one region, but if you have multiple regions, you can add another region here, and it will automatically set the source and the subscription for those content library and automate the management of these images centrally. Of course, the image is going to need space, so we're going to use the only available storage class with 4 terabytes of capacity, and I'm going to hit next and click confirm. So what this is going to do is going to go and grab the images from the source content library in the other vCenter in the management domain and bring it into the workload domain. So if we actually go back to the vSphere and go into our content library on the workload domain, you will see that we have now a provider content library created automatically on the vCenter of the workload domain. I don't even have to manage these or go into the vCenter to do these things. I'm just showing you, for the sake of the demo, what happens behind the scenes, since this is all done automatically and automated for you. So we'll leave this running, and I will touch on one thing that I wasn't planning to touch on. Before we jump into install region, so we've already created the provider content library, so we skipped the topic. But before I do that, I want to show you, for example, just talk about the supervisor for a second. The supervisor, when it was deployed, as we can see here, it was deployed and originally had 3 namespaces. But now that we've created a region through the provider portal, what we see here is now there's additional services automatically got loaded and installed on the supervisor to expand the platform. So initially we saw Velero, we saw local consumption interface, and we saw Kubernetes service. But now we see configuration service, metric aggregator for the VCF operations monitoring, integration with VCFA, And then we see VKS cluster management for controlling fleet of Kubernetes clusters through policies, image packaging, and things like that. Now, how did that happen? This is through the service management framework. In VCF automation, within the service management, we have two types of services. We have services that are Broadcom services, and then we have certified third-party vendors that also can create services to help extend the platform. When I say extend, I mean we have the virtual machine service, we have the Kubernetes service for VKS cluster. But what about if you want Argo CD? What about if you want secret store? What about if you want image repository, private registries? This is where we start extending the platform to all these services that an organization might need. And one of the things we're going to do is, as you can see here, we have installed and non-installed. The installed services, as you can see, is things like configuration service and metric aggregator. We already saw them loaded in the supervisor automatically the minute we've created a region and allocated that region to the tenant. Now, in the non-installed, I want to enable Harbor. Harbor is our regional Harbor solution that is deployed per region and helps us with centralizing management of OCI images, open container images, and also help us or serves the system images that are basically essential for supervisor services and containers, as well as we will see later, we'll actually use it to load the unified VCF CLI plugins that we can use to interact with all these services from the command line, including the packages that gets installed on the Kubernetes clusters automatically. So to do that, I can easily, as a provider, come in and enable this Harbor service and extend my platform. So again, we have one region in this demo. So I'm going to select US West. I'm going to hit next. And I think I've accepted the certificate already. Yes, I did. Select my region, and then under the service property, one of the things I can do here is edit this and make sure that, for example, I want to use the, like a password of my own. Like for this demo, I cannot be able to remember this Harbor password. So I'm going to just put the standard password that I'm using on this environment. So I'm gonna go in here, paste our password, and leave everything else the same, and hit edit. And then we're going to hit next, and that's going to take us to the resources and everything that's going to get deployed. This is all the building blocks of the Harbor instance, the secrets, the overlay, the service, and I'm ready to go and hit submit. I'm going to leave this running for a few seconds. So it'll take, for example, 30 or 40 seconds or probably a minute. But we will see that this service, and we will come back to it. So here I'm going to just increase this to 50, and you can see all these are automatically being loaded on the US West A region and the supervisor contained in that region. So very momentarily, we should be able to see the Harbor service added yet as another, or as the seventh, if you will, service that we saw get added to the supervisor services here automatically and in an automated fashion. So let me refresh here for a second. And as you can see, it's configuring Harbor. And I'm just going to leave it configuring Harbor until it's done doing so. One thing I want to quickly check on is our Content library. Content library, it's still going. And if we click on the Content library itself, we can see one important fact here, that it is actually subscribed to this URL. To this content library, and it's using this storage. And if we go into the content library, we see the two images coming in, and this is going to take time until the images get ready. Once the images are ready, they are giving a VMI number. So this is the image identifier. We will be able to use these image identifier in our manifest later on when we provision a virtual machine. All right. Now that I've done this, I'm able now to go and take a look at the organization. And as a provider, I can log in or launch into the organization portal. And let's do that right now. And let's see if we can access our org. Here we go. We're going to close this cookie usage. And right now, we're in the Acme organization that we just created and allocated resource to it, and we'll go through those. But one thing here I want you to look at and realize that there is no services. Why? Because workloads are provisioned within the scope of a project that we already have a default project, but we haven't created new projects. And more importantly, we don't have namespaces. These namespaces are going to act as our resource envelope, if you will, or resource boundary for our consumption. So when we provision workloads, we're going to provision those workloads into those namespaces. And until I create a namespace for a specific project, I have no services, and that's what we're going to do very shortly. So back to our path here. I think we're doing good. So we've installed the regional harbor as a service to extend the platform. We've created a provider content library that's going to be shared to all my tenants, and then configure private provider pricing. And this is why I left the ops or VCF operation, which is something that Kelsey did touch on when he went through costing in the previous week. So what we're going to do is when you configure VCFA and assign a region and allocate those regions to a tenant, we have to do this at least once to set your pricing for what these services are going to cost, basically, for the user. So to do that, we're going to go into configuration and scroll up to the policy definition in VCF operations. And in VCF operation, you can create a new policy if you want to. But what I'm going to do, I'm going to just use the existing default policy and click on that. And this is where I can scroll down to all the different policies, and you will see something called provider pricing. So we'll hit the edit, and let's go ahead and actually enable this pricing engine by unlocking the padlock and toggling on the enable price engine. And now I can go through all those rates, like compute rate, storage rate, network rate. We're not going to set pricing on everything, but we'll do compute. So I'll keep things to daily and using per gigahertz. And we'll say this is going to cost, I don't know, 10 cents. And for memory, we all know what's going on with the memory pricing. This is going to be a little bit more expensive. So let's say 30 cents per gigabyte. Other things we can do network rates, for example, for ingress and egress. So network transmit and network receive. I'm going to skip that. Reoccurring charges, if you want to do on regular VM or VMs used for VKS clusters. Guest OS rates. So if there is something that you're paying for licensing, like for Windows or Linux, you can do that here. I'm just going to do the one-time cost. So I'm going to say if you provision a regular VM, it's going to cost $1 per day. And if you provision a VKS cluster that's going to use a virtual machine, it's going to do $1.20. Now, you do have a rate factor here at the bottom. This is only if you're selling the service and you want to make a profit on. So if you do 1.1, for example, or 1.2, what you're basically doing is you're increasing the CPU rate or memory rate by 20%. We're not going to do that right now. So I'm just going to go and enable this as a minimum. And this is just so when we actually provision workloads in VCFA and VCF automation, we actually get that daily price estimate, and we can see the breakdown of the service that we're provisioning to the user to tell them how much this is going to cost them on daily basis. Okay, so that was the last thing in the provider section, and now we can move to the organization. Organization is got created. It's been given resources by the provider, but you are the organization administrator, and you want to take a tour of what's been allocated to you. So what we're going to do is go back to here, and we're going to actually close this and log off as the system administrator or the provider. And this time I'm going to click on change organization, and the provider already told me the name of the organization. So we know it's Acme. And now I can log in with my Acme admin or built-in account or first user, however you want to call it, that got created by the provider and given to me as the org administration. When I log in into the same org portal as the built-in Acme admin here. And the first thing I usually ask customers to do is, hey, go ahead and check what has been allocated to your organization. And this is where we can go to manage and govern and click on region. And this is going to tell us, for example, and you can always use the show details for a little bit of inline help. That's going to give us a list of all the regions that have been allocated to our organization and how much resources they have. So US West A has a total of 114 gigahertz, zero usage because we haven't deployed anything as of yet, this much memory and this much storage, and it's using this storage class. And it has access to 6 different, or 6 pages, sorry, of VM classes. So basically 16 of them, I think, or something like that. So these are all available to me as an org admin to then give out when I actually create my namespaces. We don't have any infrastructure policy, and I know I haven't talked about infrastructure policy given the 2 hours that we have. Hopefully we still able to accomplish a lot to get you started and take this and do it in your own organization. But infrastructure policy is something that you define in the provider portal, and it has to do with compute policies, so you can control placement of workloads on specific hosts. So for example, if you want your Linux workloads to be on a specific host in your cluster, then you can use infrastructure policy. There are mandatory policies that get enforced no matter what, and there are optional policies that can be selected by the user when they provision, for example, virtual machines. Hopefully we can do a full future topic if we actually continue doing this series, and we'll talk more about those little things or infrastructure policy as a placement policy that you can use to do affinity and anti-affinity of certain workloads and against what host. So now, okay, so we understand we have this region. Next, let's go ahead and check subnets. What subnets I've been allocated, and you can see I have VLAN 27 as a VLAN extension subnet that I can actually add to my namespaces, as we will see momentarily. So this is something that I can make available so users can actually select to connect virtual machines on VLAN 27. And of course, it's showing me here the IP block it's using. In the virtual private cloud, when we allocated regional networking, it told us that it's going to create a default VPC. You can actually create new virtual private cloud networking if you want to, but this VPC is default just to get you started really quick in the organization to be able to do things and test things. And it's telling me that the private VPC that we saw that we can override is this subnet, and it's using this source net. Now notice this, the source net is 9.2. It's coming from VLAN 25 because we need a public IP to be able to talk to the internet or the next hop. And that's where this is leasing the IP address from that external IP block that we've initially created. And the IP coda is okay and success. Moving on to the default transit gateway. This is the default transit gateway that got created that uses the external connection that allows us to go out. That external connection happens to be distributed. So if we go to the external connections, you will see only distributed. You won't see centralized because we haven't allocated any centralized regions in this environment. And then finally, IP management. Just so you know, this is, for example, anything with a padlock is not something that you can modify because it is coming from the provider to your organization. And you can see this is our VLAN 25. This is the 9.0, and this has external visibility, meaning it can connect to the external world. We have the TGW private. This is for intra VPC connectivity. So if you have one VM in one VPC, it wants to talk to another VM in another VPC, they can if they're connected to the private transit gateway. And then if you only want to not isolated, but private within a specific VPC in a namespace, then it's going to take an IP address from this range. All right, so we've actually, let's go back to our slide. So we did discover the allocated resource networking. Next, we need to configure a namespace class, and this takes us to what a namespace class is. So a namespace class, so I'm going to just copy the name that I'm going to use. And this is going to be under manage and govern when you're setting up things. A namespace class is really a template. So this is going to, we're going to configure certain things like CPU limits, reservations, t-shirt names, VM classes for t-shirt sizing, what backend storage, what content library. All these configuration that we're going to put into this namespace class is going to be inherited when we actually provision our resource envelope, which is the namespace for a specific project. So here we give you small, large, medium. You don't really have to use those, but this is basically based on the total amount of resources that get allocated, and it's broken down as small, large, medium. For the sake of the demo, we're going to go ahead and create one specifically for US West, because that's the only region I have in this environment. And what you will see here is that as we go through this workflow, we actually create the Kubernetes backend resource YAML that you can download and save or put in a Git repo. And we'll talk more about this as we get into the consumer side of things. So we're going to hit next. And this is option telling you that, hey, do you want to make all the zones, make all zones available and apply the same limits? This is in case the region have multiple zone. The zone is really is the backend cluster. So the cluster in the supervisor, a zone can have one or more clusters, and then the supervisor can have one or more zone for high availability. So for this, we're going to do 25 gigahertz for CPU, and I think 10 for reservation, and then for the memory is 64, and then 10 for CPU reservation, and I think 10 for also memory reservation. Yeah. So what this is basically saying is that any namespace I provision using this namespace class, it's going to have a CPU of 20 gigahertz, a memory of 64 gig, and it will have reservation of 10 to 10. So the only reason I can give this reservation, if you remember, because we went back to the region coda and added those type of reservations to the region coda. So I'm going to just click next, and this is going to take us to the t-shirt sizing. Now, what t-shirt sizing do you want to make available with a specific namespace? So on the org level, you can see we have access to all these t-shirt sizing. So maybe I don't want my users to go and start provisioning 4x large and 8x large. So what I'm going to stick with is just simply the small, medium, large for this demo. Best effort does not have any reservation, but the guaranteed small, medium, large will actually have 100% reservation based on the number of CPU and memory defined within those VM classes. So I'm going to select those 6, and then I'm going to move on to the storage class. Again, the only storage class available to our organization, as we saw, is the vSAN default storage, and we have 4 terabyte. And I think I'm going to allocate 512 for this demo. And until now, I haven't really done anything. All I did is define a template. And then we come to the content libraries. As long as the content library is auto-attached and the provider content library that we just created, it is auto-attached, there is no explicit content library that we want to enable unless the org administrator goes and create a non-auto-attached, meaning it's not going to be allocated to existing and future namespaces unless it was explicitly added. So I don't have any explicit content library, so I'm just going to hit next on that. I'm going to look at the summary and hit finish. So we've created our template. Our template has this configuration: 20 gigahertz of limit of CPU, this much memory, this much reservation, and this is the backend storage. And now I can go in and start going into the go up and click on projects. And then I have a default project. This is the first project that gets created automatically by VCF automation when you configure it. When you create an organization, we're going to leverage it. You can create your own if you want to. So I'm just going to keep calling it default project. There's no need to actually change the name. And it's thinking. I did click on it. Just making sure our environment is okay. All right. It's acting a little bit slow. okay, so it looks like we have, let's just double check on one thing real quickly. Let's refresh here real quickly. Yeah, so it's it'll come back. Give it a second. How we're doing on, I see you guys answered already 56 questions. Great job. It's the only open. Do all apps support cloud bursting to AWS? No. The all apps organization, it's a Kubernetes style API consumption model, and it's completely focused on VCF private cloud. So it does not and will not provision stuff to public cloud like Azure and AWS and things like that, like we have in the VM app. We are continuing support right now in the VM app. So if you have that kind of need, you will when you create an organization, you are able to create a VM app type organization. All right, let's see what happens here quickly. I'm just checking. Yeah, so we missed one IP here. So it'll come back, and we see the CPU is a little bit high. Let's refresh real quickly. All right. Yeah, still 3. All right, I'm just gonna close this. And let's try to open it again. Okay. Go back into manage and govern, click projects, click our projects. Okay, so we're in our projects and we have the namespaces, and let's go ahead and create our namespace. So the namespace here that I'm gonna create this is gonna called development. So you can give it a name, any name you want. And the namespace class where it's gonna inherit its setting and its configuration, it's gonna be the US West A default that we just created. This has all the CPU limits, reservation, what t-shirt sizing is going to be available. And of course, we saw that we only have access to US West region. The US West region has a supervisor that consists of one zone, and automatically we see all the VM classes and the CPU limit and reservation coming from the namespace class. So you can see basically what you're basically configuring or getting. And then our default VPC for our networking. So this is going to be the default VPC, which is VLAN on VLAN 25. Timeout. All right, so I'm going to give it a few seconds. If not, we'll switch to an offline demo that I have as a. So right now, I think during the day, this is a shared environment. And a lot of our team uses this environment, so probably why things are getting slow. Okay, so let's see if there's any questions I can answer.
Let's see, we've been kind of, so Scott and I are kind of working on that top one right now, I believe, for the supervisor. Okay, so one just came in that maybe we can answer or read aloud here. So for Cloud Burst or Autoscale scenario and Cloud Director VCD, we have an Autoscale group. Do we have a similar feature in VCF automation? Can we leverage VCF automation flow to scale CPU memory with hot add enable?
That's a great question. You can use day 2 operations to change the VM class of an existing virtual machine. So if you provision initially a virtual machine with, let's say, small, you can turn it off or change the VM class from small to large. You have to, unfortunately, turn it off. But the hot add, I will have to double check. Maybe we'll get back to you in terms of if we will be supporting hot add. I know we support it on the vCenter side, but from within VCF automation, right now, if you want to change or scale up the virtual machine, you would have to select a VM class to apply those changes. And unfortunately for now, in the VM service, you have to turn the VM off before you can select the next the upper size VM class, if you will. All right, so let's see here if we see our VPC now. Let me cancel out of this, just refresh the page. Apologies for that. So looks like the the demo gods decided to join us today. So so just give me thank you for your patience. So again, I'm gonna call this development, use my namespace class. We'll select our region. And of course, this has one zone, and we should be able to see our VPC. And we can't get to NSX for some reason. Let's see NSX. NSX is up and running. All right. All right, I'm gonna try one more time, and then I'm going to just switch to offline demo. Sorry about that. Let's see if we see no, failed to retrieve region. Select namespace class, region, zone. The thing is, you have to pick a default, like you have to select a VPC. Of course, if we go into our subnet, we won't be able to get there until searching for VPC. Let's see if I see the VPC. We do see the VPCs here. Okay. Yep, so we're getting some performance issues here, looks like it. Let me just double check. Everything seems okay from a VCFA perspective. It's just okay. All right, no worries. So let me get into the offline demo. So we already have a project, so we didn't have to create a project, and we're in the namespace section. So let me switch gears and go to my offline demo here, and we're in the organization out-of-the-box services. So we log into Acme. I'm gonna go in full screen here and log in as the org administrator. We'll move towards here in this demo, the only, actually this is good because actually we have two regions here, US East and US West. So, but I will get to the section where we start enabling the namespace, creating the namespaces for a specific projects. Yeah, I'm going really quick here. Okay, so this is a project we've onboarded, I think before we do that. Okay. All right, so once we get to the namespace class, which is our template, one thing here I do a little bit different in this specific demo is I create two namespace classes, one for each region. That's okay, and then I go into our project. But before we create a region in the default, before we create a region, we create a project called sales. And as we're creating the project, I'm adding users because we've already established AD connectivity. So here I have Connie as the project administrator. And the project administrator is someone that manages the members of the project, so they can add and remove users. They can manage catalog content, so they can create blueprints. Project content libraries also something new that we will talk about. In addition to the provider content library that gets shared to all the tenants, the org admin can create an organization-wide content library, but also the project administrator can create project-specific libraries. So that's the first role. And then the advanced user can request catalog items from the catalog if catalogs were curated and created, can also manage project content libraries and directly interact with the IaaS services as we will see enabled once we configure and once we create a namespace. The project user cannot interact with the IaaS services directly. However, they can only request catalogs from the self-service portal. And then the project auditor is just simply read-only, can view all the project content, but can't really request anything. So I've added Connie, Mary, John, and Anita. So Connie is our project administrator. Mary is our advanced user who can interact with the IS services in the catalog. John can only interact with the catalog, cannot interact with the services. And Anita is our read-only user. So we're going to hit create and create our project instead of using the default project that gets created. Now we get back to where we stumbled and click on a new namespace. Our first namespace is going to be development, Acme Dev. We're going to select the US East or West, namespace class that has all the configuration we want this namespace to inherit. It's going to be in the region US West. And this US West, actually, this is a region that includes a supervisor in the management domain for this offline demo. And then we have the option of using a dedicated VPC or a shared VPC. So here, under the VPC, we're going to see our default VPC that we saw our organization allocated before. So we're going to select that. And for this specific namespace, there is no shared subnet. So I'm going to, if you need to override any of those configuration that we set in the namespace class, this is your opportunity here as the org administrator that you can hit the override and be able to change things here, for example, from 5 gigabyte to 10 gigabyte in terms of memory reservation. And then once you're okay, you can actually hit create to create the namespace. Once the namespace is configured, it's going to get set to active. And here I'm going to proceed and do another namespace, but this time it's going to be in the US East region. Again, if you're just so everybody is not confused, we were in a live demo and the demo gods said hi. And right now we're in an offline demo where things are a little bit similar, but we're on the same path. It's just the number of regions is 2 instead of having only 1 in the live environment. And here, because we're creating Acme production in a different region, and I actually have a really nice architecture that I'll show you for what this looks like. So we're going to select US East. So what we're doing is that Acme Dev is in region US West, and Acme production is in a completely different region on a completely different supervisor or environment. Here we have also one zone, and we're going to use a shared VPC. So we're going to use the default East, but in this region, we have a shared VLAN. In our live demo, it was VLAN 27. Here, it's VLAN 2357. So we're going to select that and hit create, and that's going to create our second namespace. Now that they're created, you can always click the double arrows. You can always scroll down and edit some of these if you want to. If you want to add more resources in the future as a day 2 operations, you can do that. You can remove and add VM classes, etc. Now we're good. So we're going to go all the way. We can see the infrastructure policies here that we really haven't created any. And if we go onto the overview page, voila, now we have services. So now the services, now that we've created namespaces for a project, we see services. So if we look at the virtual, we have the namespace selector. We can toggle between Acme Dev and Acme Production. And just by toggling, you need to kind of just visualize that I am targeting an entire regional environment that could be in 2 different geographic locations just by simply going from Acme Production to Acme Development. But we're going to stick with where we are in the Acme Dev environment for now. And yeah, so this is all basically we needed to do to configure the namespace to look at our discovered workflows or allocated resources, and we can go in and sign out as an org admin. So let me go back to the offline demo list. And before we do that, I'm going to check our, let me get out of full screen. I'm going to check our slide here. So what did we do? We created a project. We created a namespace, 2 of them. We verified access to cloud services. We configured the identity provider previously through Active Directory. We onboarded users after that, and we kind of explored the cloud services. Next, we're going to talk about the cloud consumer. Let me put this in slideshow. We're going to talk about the cloud consumer experience. So we're going to provision virtual machine. We're going to explore some of the VM day end actions available to us. We're going to do namespace capture as a blueprint as one of the flagship features of 9.1 that got provisioned. We're going to provision also Kubernetes cluster, look at some of the day 2 actions, and also provision containers. And we'll see if we can set up a VCF CLI now that we don't have access to the live environment. Okay, so let's quickly check quickly on this. Let's see if this is okay. So let's get out of here and go back to our demo. And next on the list, what we're going to do is configure our identity provider as the list. So you saw me in adding Connie and John and from an Active Directory. And in here, we're going to show how an org administrator can really set up identity provider. So under administer in the org portal, you have access to identity provider. So if we click on it, we support one instance of OIDC, one instance of LDAP, and one instance of SAML. So OpenID Connect, if you want to use this as your identity provider, so you can bring in users and groups into the organization and give them roles. But for this specific demo, we're sticking with LDAP because that's what we have in this lab. And we can configure on LDAP. You can basically use VCF Automation System LDAP service if you have done this in the provider portal. So the provider portal can actually do this as well and add LDAP, and then you can use it as an LDAP service and basically simply put your distinguished name for the organization where your user resides. But since we did not set up that in the provider side, we're going to go with custom LDAP service. Once we do that, we can go to the custom LDAP and we can hit edit and provide the configuration, all the needed. So we're going to switch to Active Directory. We support Open LDAP as well. Provide our base DN, provide our username and password, and the server of LDAP server. We're using 389. It's just LDAP. If you want to use LDAP S, you can. It'll use port 636, and you will need the TLS certificate. Once this is created, we can test it out, and it can see, for example, it's connected. You have the green check. That means LDAP is created. So if we give a user like administrator and test it again, so it's connected, and we can actually close this and move on to access control now. Now that we've established our identity, whether it's OIDC, LDAP, or SAML, now we can go into and bring in groups, security groups, for example, from Active Directory. So here I'm going to import a group. My group is called labs, lab admins, lab users. So I'm just going to search for it. And you can see I have lab admins, lab demo user, and lab PM users. So here I'm going to handle the lab admins first. The lab admins are going to be assigned the org administrators. So everything, all the members of this Active Directory groups, lab admins, is going to have organization administrator role for the Acme organization. So we're going to hit save. And then the next one I'm going to do is our lab users. This is where John and Connie and Anita that we've added in the previous demo going to live in. So lab demo users, they're going to be given at a minimum the org user role. Just to make sure I be clear here that this is org level roles. So I am giving org administration level and org user level. So you have to be an org user to be able to later be added to a project, for example. All right, so we've added lab admins and lab demo. So here now we can go in, and this is how we were able to add those users that we saw when we created the sales project. All right. If we choose now, you can see in the menu, we see log in with LDAP, and I'm logging in as the administrator at that domain. And you can see I can log in using LDAP, not using the first built-in user for this organization. And so it's working as it should. So we're gonna sign off here. If we go to the account, of course, we can see that this is the administrator account. And if we go to administer, we can now add other users, I think. Yeah, that's it. So administrator. So because we've logged in as the administrator at domain, you can see that the administrator is now listed. You won't be listed under users until you make that first login, or you import users manually. And you can see the difference here between the local admin that the provider that the provider admin gave us versus the LDAP provider type. So this is how you differentiate between which is which, basically LDAP versus OIDC versus local versus SAML. All right, I think that concludes this demo, and then we can go back to our list just to see where we are in our journey here. Not this. All right, so I think I went too far. Yeah, so here we said configured identity provider, we onboarded user, and now we're gonna go and start provisioning. So the first thing we're gonna do here is basically provision a virtual machine. So let's go and take a look at how that looks like. So I'm gonna go into my offline demo and then provisioning virtual machine. So here I'm gonna choose my organization, of course, Acme, like we always did. I'm gonna use LDAP to log in as Mary. And Mary, as we saw, is an advanced level project user. So Mary has two roles, has an org level roles as an org user, and it has a project level roles as an advanced project users, which means, if we all remember, she can interact directly with the services. She can go to the catalog and request catalog items. She can look at the top utilization. This is the top utilization coming from the integration with VCF operations. So she can also go into and select the namespaces that are created within the project she's a member of. She's part of project sales, and we've created two namespaces in that project, as we saw, Acme Dev and Acme Production. We can see them all here, for example, and we can select which namespace we want to target. Or next, you can simply go to build and deploy to access those services. Or I'm just showing you the shortcut links that we have available on the overview page. If we click the services overview, it takes us to the summary page of that namespace that we've selected. And then we can see all the core services, virtual machine, Kubernetes, container, that we can actually leverage in the and self-service by interacting directly with the services. We can see what region this namespace has been created. We can see the name and what project owns it, being sales. It's active. It has 6 VM classes, t-shirt sizing, and it's using the default US East VPC for the networking boundary. This is how much total utilization in memory. This is how much storage. We haven't provisioned anything really. Also, you can see this little monitor tab on the namespace level. This is monitoring coming from VCF operation platform to show us usage limits and reservations on a namespace level. So we see the CPU basically limit reservation and usage. Usage is 0 right now. Our limit is 100 gigahertz, and the reservation is 10 gigahertz. Same thing with memory, limits, reservation, and consumed. We have disk space, and we have a summary of the number of total virtual machines versus which number of them running and which is not. So we can compare to see the number of running VMs versus the total based on the coloring. And then if we go back to summary, we can now look at all the services available to us here. And we can go to the service. We can go to the create virtual machine workflows directly, or go to the service first to see the list of all the virtual machines that my teammates or my project mates members have created before me, none exist right now. And we can start going through the create virtual machine workflow as the first workload that we're now provisioning after gaining access to these services. The first thing we need to pick the source type. We support OVF and ISOs. So OVF is the OVA-based templates, has a lot more options than an ISO. An ISO, if you're provisioning directly from an ISO, you download it from the vendor, for example. Also, notice that anytime we go into the next, and for example, here in the deploy new VM, we're going to provide a name. This is going to be our VM Linux 01. And anything I do in the UI, it's automatically generating on the right-hand side my Kubernetes resource YAML. And the Kubernetes resource YAML is what is going to be declared. What I'm doing here is that I'm declaring what this virtual machine needs to be, and then that declarative state is sent to the supervisor at the back end and to the infrastructure, and then that is realized, and taking that declarative state and making it a real active state by provisioning the virtual machine based on our selections. Of course, this is done directly from here. I can take a copy of this manifest. I can put it in source control later on to use it with things like Argo CD for continuous deployment and using GitOps as the source of truth for the declarative infrastructure that I am doing or I want to implement. In the infrastructure policy, remember I mentioned there is optional and mandatory. The users will see all the optional infrastructure policy, which is again placement policies. So if you're provisioning a VM and maybe you want this VM to be a disaster recovery protected, you might have an infrastructure policy that's going to place this VM onto a host that is disaster recovery protected. So right now, we only have Windows as optional. This is not Windows. So even if you select Windows, it's not going to work because this infrastructure policy has a condition to look for the family OS type of the workload. So we're not going to really select anything here. But again, remember, infrastructure policy is really placement if you want to establish those kind of rules. Next, the zone can be automatically selected based on the infrastructure policy that you select above. Or one thing here to note is that anytime you want to add additional disk space, make sure to select the zone. Otherwise, you will not be able to add additional volumes to the virtual machine. So here I only have one zone. So now I can actually attach volumes. We don't have any VM group defined, and we'll talk about VM group shortly. Next, I'm going to basically click on this to go and select the VM images available to you as a user. And remember, in the initial demo, we did a provider content library, and we had 2 virtual machines. Here, we have a lot more. So you can control, as an org administrator, what images you want to expose to your project users. And this is a great way of controlling certified, scanned, secured images sanctioned by your security team at your organization to make sure that your users are using images that available to them. So we're going to use Ubuntu 24. I've chosen Ubuntu 24, and you can right away see on line 12 is the image identifier of that image. So any image that we upload to our content library automatically get parsed and gets generated a VMI ID. Of course, it's being leveraged in the manifest, as we can see here. And we can move on to the VM class, which is t-shirt sizing, which is what are the virtual hardware specification for the workload that we're trying to provision. I'm going to go and select best effort small, where there's no reservation. This is the difference between best effort and you see guarantee. And by the way, this is default on the supervisor. Like if you want to add more VM classes that uses GPUs, for example, if you're provisioning AI workloads, you can create those on the supervisor, and then it gets made available by the provider to your organization. So you can select it when you want to use those. All right, next we can add additional disks if we want to. And because this virtual machine, the first one I'm going to provision is going to be on a private VPC subnet, I can expose certain services. For example, I want to be able to SSH into this VM. So I'm going to define SSH as a target, and the port and the target. This is the port on the load balancer, and this is the target at the back end, which is the virtual machine. And the minute I do that, look at the YAML. It's another manifest for virtual machine service documenting the desired state of the load balancing service that I want, exposing SSH on port 22 and leveraging TCP. Scrolling down to the big thing here about bootstrapping. In the all apps, and because of the Kubernetes style API, gone the days where we use a 20-year-old technology like custom specification to bootstrap a Windows or a Linux machine. Now, and just like public cloud providers, we use Cloud Init for Linux, which is typically what's used across the board to bootstrap virtual machines. Sysprep for Windows, and we actually use inline Sysprep here, so you can actually stay away from all that ugly XML when you use the unattended install. And then you have Linux Prep for VMware legacy Linux-based. This is specific to VMware, and then VApp config is when you're provisioning ISO or OVA, where it's in. Sorry, not ISO, OVA. Expecting inputs, things like, hey, what's the root password, or what's the network I'm gonna connect? This is for things like network devices or appliances, if you will. So since this is Linux, I'm gonna select Cloud Init. You have two types of configuration here, where we can do standard inputs. Let's say you're not that familiar with what a Cloud Init. I really encourage you to go to check the Cloud Init, read the docs. They have great examples of what a payload should look like, and I'm going to show you a payload here. But if you don't know, you can just use a standard input, or if you have a Cloud Init payload in your organization that you use on day-to-day basis, you can go to raw configuration and just dump it there. And I think we will do that momentarily. So I'm going to select my time zone. I'm in Toronto. So America, Toronto's, you can enable the default user on the Ubuntu image. You can create new users if you want to. We'll create a demo user, and we want to enable, maybe add it to the suitor group. If this user, you have an SSH authorized key that you have the private key to, by all means, you can add your SSH keys here if you wanted to. I don't. So here we go. So I added mine. And I'm going to add this, and we can see the SSH key added for this user, and I'm going to hit save. Next, do you want to enable SSH? Well, I've just enabled the certificate, but why not? We're going to enable SSH password authentication, so you can SSH into the VM that we're provisioning. And finally, run commands. This is done on a command-by-command basis. Obviously, this doesn't scale, even though it works. This is where raw configuration comes in to provision something a lot bigger. I'm gonna hit add, and once we hit add, you can see in the spec section of the virtual machine, starting with line 16, our bootstrap. So we chose Cloud Init, our cloud config, all the stuff that we've kind of selected, like the user we're adding, the command that we're gonna run. We're gonna run hello world and temp it and pipe it into, for example, welcome.txt in the temp folder. And then next, we come to the network configuration, and we can attach 10 virtual machines. But here, this is where we can edit the existing virtual machine, and you can see all the different subnets available to you as a user based on what the provider made available to us. So we're gonna cancel here and continue to use the default private subnet set, which is a private VPC connected to the default US East VPC that was assigned to the organization. So hit cancel, because we've created a load balancer that exposes SSH. We're gonna provide our domain name, our name servers like DNS, and our search domains. And of course, we can see all those being reflected in the YAML. Next, we're gonna review and confirm. Before we do that, what we can do is actually download all these three, the virtual machine, the bootstrap information, and the load balancer, all in a zip file on my machine, so I can upload those maybe to a Git repo, or maybe use those to deploy the same VM or customize them to provision new VMs from the VCF command line. Before we do, and because we've enabled the provider price policy in VCF operations, we're able to see daily price estimate, and we can see it's cheap, $2.40 US. And if I want to see a breakdown of this daily price estimate, it's going to tell me, 80 cents is coming from compute, 3 cents coming from storage, and additional charges 1.6 being virtual machine one-time fixed. And now I'm ready to go and deploy my virtual machine. We've sent the declarative state into the cloud, and the VM is going to be realized based on that declarative state. and my VM is up and running. It's powered on, it's ready. It has an internal IP address. And this is the image it's being used from. The next, and I'm going to go and this one a little bit faster, very similar to what we've done before, but this is going to be a MySQL VM. And the difference here is that in this MySQL VM, we're not going to create a load balancer because we're going to just place it on a public subnet. So we're going to use our t-shirt sizing. And as you can see, I'm skipping the load balancer. On the Cloud Init, though, this is where I can go and actually leverage the raw configuration and dump my Cloud Init payload. And I'll show you how that looks like. As you can see, the payload is basically user data. This is my Cloud config. So I am updating the package repo. I'm upgrading any available packages. I'm also downloading these packages, MySQL Server, a client core, unzip, OpenVM tools, and then I'm creating the users that I want. So I'm creating a demo user. It has its own SSH keys, and I'm creating another user for my my database. I'm writing some files. By the way, all those payload are fairly documented very well in the Cloud Init read the docs. So make sure you Google that. And then lastly, here are the commands that I'm executing. So I'm doing MySQL commands to create my database, open card database, I think it is. And then that's the entire payload. So instead of using standard input, I'm using raw configuration. I'm gonna hit next and to the network. And instead of using now the private subnet, I'm going to edit this and actually use the VLAN 2357. In the live demo, it was VLAN 27. I'm going to hit save, and I'm going to also do the same thing, provide all the metadata for all my networking, like search domains, domain names, etc. And let's add this one here. And just like before, next, and download our Kubernetes resource YAMLs, look at the estimated price. And here, this virtual machine has a different IP address since it's not connected to a private subnet. Where these IP address came from? Remember the external IP block that we defined? You don't need an IPAM in this situation. It's really automated to be able to just define the regions that you want to use, and they will automatically lease IPs and release IPs back to those sort of IP block. So if we actually open this, we can see things like the active YAML. Again, we've sent the desired state of what we want to accomplish, provision a VM. That has MySQL on it, and we can open the remote console to it, the web console. It's powered on, it's in zone 1. We can actually click into it actually as well to see day 2 operations. So it's powered on. We can toggle this to power it off if we want to. We can edit the infrastructure policy. Here it happened that a mandatory Linux placement policy has been applied to this virtual machine because the provider basically enforced that kind of policy, placement policy on the Acme organization. We can add labels. We can also, if we scroll down, we see the network. We can add additional network interfaces if we want to. We can see that it's connected to VLAN 2357, our host information, volumes, if we want to add additional volumes. And one very important note here, the additional disks that you create here, those are independent. They have their own independent lifecycle, independent of the VM lifecycle. So if you delete the VM, you can actually keep the volume behind and reattach it to a new VM that you provision because it's not sort of connected to the VM itself. You can actually have an option to delete it with the VM if you wanted to, but you can always have the option to keep it behind because it happens to be managed independently of the VM itself. So if we go up, scroll down more, this is the volume that got created on the virtual machine, 10 gigabyte, all the conditions and some of the events that happens on the VM. So this is good for troubleshooting. We can open the web console into the virtual machine, log in with our demo user, and you can see automatically when I logged in and put the password, I went into VM MySQL 1. So if I actually check let me click here. If I do sudo -i to switch to root, and go to MySQL and log in with OOC user, enter, and you can see it's still running. So MySQL is not there yet. So one of the things you can do here, this is just a pro tip, you can do cloud init status -- long, and you can see here that it's still running. It's still executing the bootstrapping, for example, in the VM. And then if we check again, it's already done. Now, if we do MySQL and try to log in into our SQL database, it actually prompts us for the password. And here we go. We're at the MySQL prompt. I can say show databases, and it shows me the databases that I created, which is the OpenCard database. All right, going back to the VM and continuing on a day two operation that you can accomplish with a virtual machine is snapshot. So we can take a snapshot, edit it, revert it, delete it, just like if you do in the vSphere CLI. And on the monitor tab, and just like we saw the monitor on a namespace level, we can actually see the virtual machine monitoring. Of course, the machine was just deployed. You can see this little dot of data. Remember that VCF operation collects data on an interval of 5 minutes. So we basically see those kind of utilization data coming in now that the VM is provisioned. And on the guest customization, it's just information on, just information in terms of that it was bootstrapped with Cloud Init. All right, so go in here, and I think that was the end of the demo for virtual machines. So any outstanding questions I can answer before I jump to the next one. Also, how are we doing on time? I think it's 15 minutes left.
Yes. Right now it's it's 12:41 Central Time. Yeah, so I think you got about 15, 20 left.
Okay,
yeah, I think we're getting to the questions pretty well. So yeah,
perfect.
keep on plugging away. Yeah.
All right, so what we did here so far, we provisioned virtual machine, we explored some of the VM day two in action. Let's go ahead and tackle this one here, since we're running a little bit low on time, is the namespace capture as Blueprint. And this is really, really exciting. I don't know if we're going to have time to go through the provisioning of VKS clusters, but it's very similar experience as the virtual machine. Instead, that the workflow is going to take you through a lot of different options you can choose from. You can make it so much basic, or you can make deploy a very detailed VKS cluster in terms of all the different Kubernetes cluster settings that you want to apply. But I want to make sure that I hit on the namespace capture as Blueprint next. So let's do that. All right, in the namespace capture, one of the things we can do is we're going to log in into our organization. Let me go in full screen here. Log in as the admin. And the first thing admin is going to do is going to go to manage and govern and go to sales and go to the namespace self-service. So so I'm talking about the namespace capture as Blueprint feature, but underneath that feature, there are 3 to 4 different new features in VCF Automation 9.1. And we're going to tackle on that. And this is the first one of them. You're allowing, as an org administrator, you're allowing the project administrator with all the necessary provision to be able for themselves to create namespaces. So it doesn't have to be the org administrator that only creates the namespace. The org admin can configure this namespace self-service for a specific project. In this case, it's our project sales. And what I'm doing here is I'm going to select all the different values I want to expose to the project administrator so they can go and create namespaces with things I want them to use. So I want them to use only US West. I don't want them to create namespaces in US East. Let's say you're running tier A application that will cost money if they go down, or will cost your company money if they go down. So maybe this is not something I want them to create resources in. So next, what namespace class, for example, you want them to use? We gave them access to US West region, so I'm going to give them access to the namespace class. And we all know now what the namespace class is a template with all the configuration and namespace would inherit once it's provisioned from. Next, networking. Do you want to allow them to use shared VPCs? And allow them to use maybe dedicated VPCs? You have the option here as an org admin to set all these guardrails for what they can and can't use. So we only want the project administrator to be able to allow shared VPCs and use the default US West, and then hit next. And then, okay, are there any subnets you want them to? So we saw a subnet for this specific one, because we've selected US West and not US East, we don't have any subnets. Remember, the shared subnet that we added was in the other region. But if the subnet would show up here and is available in this region, you can allow them to add this subnet to their namespaces. So same thing with infrastructure policy. There's no infrastructure policy to expose to them to select from. So this is made super simple. We can review and confirm. And then we have a namespace self-service created by the org administrator for the project administrator group for project sales. And we can always go in as the org admin and add or remove or modify this name self-service. Maybe now they want to add the second US East region, so we can add that for them. So we can see all the different things that we've added here, including adding and associating subnets in the future or connectivity profile if they want to create dedicated VPCs. If we go to build and deploy and go to our content library, we're going to go to number requirement 2. For namespace capture, which is another new feature, which is project content library. Remember how we saw the provider shared content library defined on the provider and then pushed to our Acme organization or to all organization defined with or managed by the provider. And here we have a new content library called project level content library. This is going to allow us to create a content library specific to one or more projects, not organization wide. Right? So it's not going to be available for every other projects, only projects that we select as the org admin. The other thing that you can do, this is also where we capture, when we actually go through the actual capture of a namespace with workloads in it, virtual machine workloads, this is where we're going to capture those VM images too. So that's another thing. And this is why the project content library is one of the dependency of getting to the namespace capture feature. So I'm going to hit next. And because we want a writable project, I'm going to make sure that this is only going to be available for project sales. If there's other projects, you can also select them. And I don't want them to be read-only because we're the project administrator now giving the self-service policy that the org admin gave it is now able to create namespaces. And when they capture a namespace, they want to be able to write into this project content. So we give them read and write. Next, the region we want this to make this available in. So this is for US West, and this is the backend storage, leveraging the storage class where these images will be stored on. Once we hit next and we confirm our selections, we have a sales content library, which is of type projects, owned by project sales, or project sales has access to it, is not subscribed, and it's version 1 and the creation date. Now we can go to the overview and start with the, go to the VM service and go to the number 3 dependency for the namespace capture feature. And that is VM groups. VM groups is a new feature in VCF Automation 9.1. And it allows you to create a group where you can add VM to, as long as they share collective operations like, hey, I want to turn all these VMs at the same time, or I want to control the boot order of those virtual machines in this group. Let's say if you have 100 virtual machine and they have to, all the infrastructure VMs has to come up first, like databases, Redis, memory, whatever, sort of object store, virtual machines or workloads, those has to come like before the middleware applications or the front-end applications like web servers go on. So this is something that you can do with VM group. But it also happens to have, for a namespace capture to work, you need at least one VM group enabled. So since we have Linux workload, we're going to call it Linux VM group. We want the power state of this VM group, the desired state of this VM group to be powered on. So we want all the machines to be powered on at first. And then we can go and select the 2 VMs that we just provisioned, VM Linux 1 and the SQL VM, or VM Linux 2 in this demo. Here in the start order, this is where I can define the sequence in which VMs powered on. So I have only one wave here. I can create another wave and then go to this wave and say, hey, bring in, for example, VM2 here as the second wave and introduce a delay of 30 seconds or 5 minutes or whatever delay time you need for this VM or for this wave and all its members to boot after the wave 1 is completed. Once we're done, we hit next. We also see a representation of the Kubernetes YAML of type virtual machine group custom resource, and the boot order as we defined it, and the power on delay and the power state desired state. Again, we send the desired state into the cloud and it gets realized, and now it's ready. Now that I have a Linux number 4 as a dependency for namespace capture, before you can actually capture a namespace with its workload, the virtual machines, these virtual machines needs to be turned off. So we can see the membership here in terms of the virtual machine, and we see the start order at the bottom. So if we can click here and say power off, it's going to go off and power off all the member of the VM group. So it's going to power off everything. So the power state now of the VM group is powered off. And if we click on the virtual machine, we can see our virtual machines also have been powered off. So we did a self-service namespace. We did a project content library. We created a VM group and we turned off the virtual machine. Now we have capture as blueprint on the overview page right on the top is capturing virtual machines. And just as a side note, the only workloads that you can actually, we support today as of 9.1 is only virtual machines. So you can't have Kubernetes clusters in a namespace when you want to do the capture. Your baseline has to be a namespace with virtual machines. If you have containers, it will be skipped, but it will not block the namespace capture. But if you have VKS cluster, it will tell you you cannot do a capture as blueprint. Once we kick off the capture as blueprint, we go through some validations to check the namespace, to check the status of the network mapping, etc. And then we are guided into the workflow blueprint, create blueprint workflow. So this is the Linux group capture. So we're going to give it a name. So this is the name of the blueprint. And this is where it needs now the project content library to say, hey, where is the content library where I'm going to take those images from those 2 virtual machines and copy them to? Because the idea here is that we're capturing an environment. Could be an identical capture, that's the capture customization mode, identical copy, or it could be capture with customization. So you're defining a whole environment. This could be an AI environment. You've deployed all the inferencing VMs, all the database VMs, all the PG vector related to AI workload, or let's say sandbox, and you want to capture it and you want to create infrastructure as code, generate that code automatically, and then place it in the catalog so other data scientists or developers, AI developers can use it to deploy this sandbox environment every time, multiple times without collision. So we select the sales content library where we want to go and capture the images, and we can go and look at some of the found issues. Some of these issues are going to be informational and some of them are blockers. The thing I want you to understand is that there are 2 sections here when it comes to warning. There is the capturing namespace sections, and here, this is basically saying, and this is informational, saying that the VMs have already booted and they have already a bootstrap configuration. We will remove them from the blueprint generation so they don't get, for example, customized again. And then the second section, the bottom section, is specifically when you want to take an identical copy. For example, one of the biggest blockers, or one of the blockers of identical copy, is you cannot use a shared VPC or a namespace using a shared VPC. The namespace you're capturing as identical need to have a dedicated VPC, not a shared one, meaning not shared by many other namespaces. It should have its own. This is why you see here, it says, hey, default US West is not dedicated. Therefore, I cannot prevent IP and MAC address retention. Therefore, you will not be able to do identical copy. Well, okay. So these are some of the guides that will guide you through this process of namespace capture. Just wanted to make sure. And because of that, and because we're using a shared VPC, we can't really do identical. So we'll stick with capture customization and go from there. The customization with captures allow you to allow users, if you want to pick different VM t-shirt sizing or VM classes. These will be VM classes available out of the available VM classes in the source namespace that we're capturing, which is in this case Acme Development. So if you don't want the user to change the size of the VM, then you don't check this box. Next, we get guest OS configurations and settings. So here there's two different user experiences. I can select all the VMs and hit configure. And I'm going to continue to say use cloud init, and then you want auto-generate password, or you want the user to specify the password. This is the user of the basically the root password. And in our case, we used Ubuntu, and Ubuntu by default disables the root user by default, but we're still setting password for it. So if you enable it in the future, it will, or you can set it to none. Because remember, when we actually created the those two virtual machine, we defined a demo user or a user called demo user. So we're gonna say, okay, let the user specify the password. The other, when you select all the virtual machine, you are not able to select the host name. But if you select one and hit configure, you will see the host name field, and now you can change the host name if you want to. But we're not going to do that. So I'm going to just deselect that. And we're going to hit next. And now
I'm here real quick, just time check, 4 minutes. Just want to let you know.
Yeah, thank you.
Okay.
So now we're able to do the capture. So the capture is going to be, will give you a capture in progress. You can see all your recent captures in the recent capture tab. And if we click status, we can see the capture. You'll get a pop-up that the capture has been successful. And you can actually view the status by clicking the refresh here. We can see it's completed. And if we go into the capture, we can see what happened. We can see that we did a capture data completed. We did validation, which was successful. And we published 2 images. These images are now in the Project Content library that we created for the sales project. And we've created a blueprint. So let's just go ahead and the blueprint design. So the blueprint design is, these are declarative YAML. They were in there in VCF automation and ARIA automation before. It's available. The blueprints and templates are still available in the VM app org as well as they continue to be in the all apps here. And you can see we can create blueprints from scratch. We can bring them from Get. But this namespace capture took the 2 virtual machine and created from the ground up a fully generated blueprint representing that namespace and its workload that we just captured. So you can see the namespace. We provisioned this in, and you can see the inputs on the top here. These are because we checked that box that the users can allow the user to select multiple size or different sizes. We can see inputs created to select the VM class. We can see the resources or the output. This is an output tab where we tell the user information about the application they just deployed from the catalog, or in this case, the IP addresses and the power state of each of the VM. We can see the resources. You can see the namespace is already created here. This is going to be based on the namespace source that we captured, the namespace source that we captured. This is your opportunity now as a project administrator to go in and modify these limits, because you want to make sure that you still have, for example, 50 gigahertz in your org as resources. If you don't, of course, this is going to fail, saying there's not enough, or the requested CPU or memory does not really, is above the limit of the organization. You can also use this to add additional workloads like containers, like VKS clusters, into this namespace, but you just established your baseline to capture this environment. So quickly, and because we're running out of time, I'm going to publish this environment, and I'm going to hit close. When we publish it, it becomes available in the catalog as something that you can request. So the next user can come in and actually request the environment, give it a name, and because we allow the user to select the different VM classes, they have the option to choose different t-shirt sizing, provide their password for the first VM, provide the password for the second VM, look at the daily price estimate as well, and a breakdown if you want to view the details, and submit this. And what it's going to do now it's going to create a namespace on demand, and it's going to create these deployments. And of course, just like any deployment or catalog instance, we have day two operations on the deployment side. And if we click into this deployment, we can see that all the components it provisioned, and we can see the topology. Before the topology, we see the overview page we saw where you can control and put more information here for the user. So we see the two VMs, their status, and in the topology, we see a similar topology as we saw in the blueprinting, right? So once we exit from here, we go to the virtual machines. You can see that original virtual machines that was used using the virtual machine service is off, and we have two exact customized replica of the virtual machines that we captured. Now, if we go into the vCenter, just to show you how this looks in vCenter, this is the namespace that got created in addition to the Acme development where we captured. This is the Acme development that we captured initially, and we see the workloads. And if we go to the Acme development where we captured the namespace, we see the same workloads, just simply turned off. Okay, so I think we can stop here and maybe answer some questions. And I think we're at time, unfortunately.
Yeah, and I think they've done a good job of getting all the questions. There are some comments about, hey, this was a lot. We had to skip some parts. Can we maybe have more of these? And I think the answer is yes, we will definitely try to follow up with more. We've got a lot of great feedback from the sessions we've had before. And if you kind of look at the screen, we've in the last 5 weeks, we've gone through a lot, everything from designing to deploying to creating workload domains to using VCF operations to a deep dive in automation. It's a lot to go through. So now with the feedback we've got, we know that people want more information on upgrades, more information on networking, more information on some of the Kubernetes pieces. And so we'll definitely do that. My ask to the attendees is to make sure they fill out their surveys and give us that feedback. We will definitely be looking at that and using that as we plan for future sessions. And I want to thank Maher. I want to thank Vincent and Scott for all their help, and all the other experts for their help in the Q&A. And mostly want to thank all the attendees for sticking with us as we went through this initial adoption series. I think it's been very successful. We've got a lot of very positive feedback, and it's definitely something that we see as a start of something that we hope to continue to do as we go forward. Again, everything is posted, everything's available, so you can go back and review and watch any sections that you may want to revisit, and those links will be available. If you don't have the links, just go out and do a search on YouTube for the VCF webinar series, and you'll find the things. Thanks, Simon, for hosting this and for giving us this opportunity to get in front of customers and to share this information. And with that, I think we can wrap things up.
Yeah. So just one last thing before we close. We do have already these video series out on our VCF YouTube channel. So this is the QR code. This is the link. It will be in the slides once it's shared. The VCF Automation 9.1 video series. So make sure to look for that. We do exactly the same thing, but at a bigger scale. Thank you.